Right. So you're going to continue from where we ended in the previous video, where we looked at the theoretical overview of maximum power transfer and how we and when we utilize the formulas that we are supposed to use, and obviously what maximum average power transfer is all about. So we are going to find the load impedance, and we also have to calculate the maximum average power transfer. So I'll not really go deep into like trying to explain where the formulas are coming from. If you haven't watched the video, the previous video, check the link of the video in the description below, and make sure to say you watch it, understand, then that's when perhaps you can come back and watch this one. Okay. So the first thing that we have to understand is that for me to find my load impedance, because the question is saying find the load impedance that absorbs the maximum average power transfer. So for this part here to absorb the maximum average power transfer, remember to say after everything that we went through, we came to a conclusion that the load impedance, okay, we came to a conclusion that the load impedance ZL is equals to the complex conjugate of the what of the Thevenin impedance. So all we have to do is that all we have to do here is just to find the Thevenin impedance. Then the complex conjugate of that Thevenin impedance is simply our load impedance. All right. So and one thing that you also have to keep in mind is that your Thevenin impedance is the way you find it is just the same method that you used to find um, the Thevenin resistance. So like we have that circuit right here. Okay, we have that circuit where we have a resistor. Okay. hmm let me not draw it that way. It's much easier for me to draw it this way. um, that's the 8 ohm resistor there. Okay, then here I have my minus J4 ohms capacitor, and I'll come like here like that. Then I have my inductor here. Then I have another resistor at this point, which is my 5 ohm resistor. So I believe you understand why I'm not including the supply current there. So when you're finding your R Thevenin, you're supposed to switch off your independent sources. In this case, since I have a current source, you're going to have like if you switch off a current source, we said what you're going to have is an open circuit. If that was a voltage source, we could have said we have a what? We have a short circuit. You could have just been a what? A wire, just a wire like that. Okay, but because but because it's a current source, we're going to have what? We're going to have an open circuit of which we're going to say the resistance there is what? It's up to infinity. So at this point, this is where we have what? Our Thevenin impedance. So to find our Thevenin impedance, here is how we go about it. So we're just going to say the Thevenin impedance is just equals to, you observe to say the 8 ohm resistor, the minus J4 ohms capacitor, then we also have the J10 ohm inductor there. Of course, we have the 5 ohm resistor. So these three, this one, that one, and this one, they are in series but in parallel to the what? To the 5 ohm resistor, which is that one there. And here's how we put it. We're just going to say it's the 8, okay, the 8, then minus J4, okay, plus what? Plus the J10, okay. So we observe to say these are in parallel to the what? They're in parallel to the 5 ohm resistor. Okay, so we break this down further. So the Thevenin impedance is going to be equals to, so you have your 8, okay, then you have your minus J4 plus J10, that will give you what? Plus J6. Okay, so you have the real part, which is 8, and the imaginary part, which is positive 6. Then we say this is in parallel with the what? With the 5. And the same way we treat resistors when they're in parallel. So it's like we have two pairs here. That's the same way that you treat what? That's the same way that you treat these. It's more like you have your A and your B here. What do you do when they're in parallel? It's your A times your B divided by what? A plus what? A plus B. That's the same thing that we are going to do right here. Okay. So now we can come and say it's the 5 multiplied by the 8 plus J6 divided by what? divide by what? Divide by the 5 plus the 8 plus j6. Okay, so now 5 by 8, it will give us 40, plus 5 by 6, that will give us 30. So it will be j30 there, divide by, so you have 5 plus 8, that will give us 13, plus j6. So for you to come up with the final value of the or for it to get closer to the value of the Thevenin impedance that you are looking for, I think it would be a wise thing for you to convert this to polar, so that you continue from there. It's much easier for you to deal with rational expressions in polar compared to rectangular. So converting that to polar, I have the 40, okay, um, 40 comma 30, giving me, I have a 50. Okay, then the first angle of that, that's going to be 36.87 degrees. That's the angle that I have. Then converting the denominator as well, which is 13 comma 6, what I have is, I have 14.318 with the first angle of 24.78. So what do we do? What we do at this point is just, we can say 50, you can just divide 50 divided by 14.318, that is going to give us 3.492. Okay, then for us to find the first angle, is supposed to subtract 36.87 minus 24.78. That will give us 12.09. So now we have said the load impedance is just a complex conjugate of the Thevenin impedance. So for us to find that, it would be better, instead of us using the polar form of the Thevenin impedance, we use the rectangular form. So you have to convert that value that we have into rectangular. So that is 3.492 comma 12.01, sorry, 12.09. What we get, or what I get on my calculator, is I get 3.41454667, of which if I round off to 3 decimal places, I'm going to get 3.415. Okay, then the imaginary part, that will be plus 0. In fact, it's j 0.731. Okay, this is what I have as my Thevenin impedance. But remember, the load impedance is just a complex conjugate of the Thevenin impedance, of which the complex conjugate of what we have right now is simply 3.415, instead of plus but minus j 0.731. Of course, we are using what? We are using ohms there, and that's the value that we have. And I'll save it there. I'll leave it there. We might need to use it at some point. In fact, we are going to use it, especially this value that we have here. So we have found the load impedance that absorbs the maximum average power transfer. Now the next thing that we have to do is that we have to calculate that maximum average power transfer that we are talking about. And to remind ourselves, we said Pmax, or maximum average power transfer, is equals to absolute value of V Thevenin, or Thevenin voltage squared, divided by 8 by the Thevenin resistance. Okay, so for the Thevenin resistance part, Thevenin resistance part, the value that you're going to use is this same value that we have here, which is a 3.415. Okay, then the Thevenin voltage, we have to do some calculations there. So to find the Thevenin voltage, I'm just going to use this same circuit that I had to put down here. Okay, or perhaps I can just utilize this same circuit that we have here. So it's more like, here you have wait a minute, so it's more like here I have a terminal, and here I have a what? I have a terminal. Let's just say this is not there. Let's say this is terminal A, terminal B. Then you're looking for what? You're looking for V Thevenin. You're looking for V Thevenin there, okay, which is the same as what is here. So now it's up to you which method that you want to use. Do you want to use node analysis? Do you want to use mesh analysis? And whichever method that you are going to use, it all depends on which method that you are comfortable with. And again, there are some methods that can be tiresome when you're trying to use them on a certain circuit. Some will be much easier, and according to me, the method that is much easier for us to find the V Thevenin for this circuit is the it's a nodal analysis. Okay, so here I'm going to put for myself a voltage there. Okay, I'm just going to indicate it as V. Then I'm going to ground this part. Okay, and we know to say on the ground the voltage is 0. So I'm going to put up currents. Okay, so remember to say nodal analysis is like that's simply KCL, or the Kirchhoff's current law, where you're going to use your currents to find the voltages. Okay, unlike the KVA, where you're going to use the voltages to find where to find the currents. Here you're going to use the currents to find the voltages. So here I'm going to say let this be I1. Okay, then from V to V Thevenin, let me name this as my what? My I2. Then from V Thevenin coming down, let me name this as my what? My I3. Okay, so I have a node here and I have a node here. So what I'm going to say is at node V, what you have is that if you apply nodal analysis there, you're going to have your minus V divided by what? Minus V divided by what do we have? Divided by 8 minus J4 ohms. Okay, then that will give us we say plus the 12 amps current. Then that is going to be equals to what? That will be equals to the V7, I mean just the V minus the V Thevenin divide by what? Divide by the J10 ohms inductor. Okay, so it's just more like we have this current is entering that node, same applies to that one. Then we have I2 that is leaving what? Leaving that node there. That's why we have what we have right here. Okay, so before I go to before I go to the node at Thevenin there, I can try to simplify this. I can write this as V minus V. Oh, by the way, just in case you're wondering why I'm using a minus V here, it's simply because I'm saying the voltage that I have at this point, at any point here before this one, minus the voltage that I have here. It's like your initial voltage minus your final voltage divided by the what? The load that you have, which in this case is the 8 minus what? Minus the J4. So that's why that V is there. Is what? It's a minus. So I can say it's minus V, then plus, that would be 12. You can I want to make this a single fraction, then that is going to be 8 minus J4 there. Okay, is equals to. So remember to say this was supposed to be here on the denominator, like I write 8 minus J4, but I'm not going to do that. It's more like I'm doing the cross multiplication thing. I'm just going to put it this side, where I'll have what? My 8 minus the J4 divide by J10 multiplied by what? V minus V Thevenin there. Okay, so I want to settle this side in advance before I go to the other node. So what we have is that we have minus V plus 12 times 8, that is probably 96. So 12 times 8, yeah, that is going to give us 96. Then minus 12 multiplied by 4, that will give us 48. That will give us minus J48 is equals to. So I'm going to have to work something out for that part. So the best thing to do right here is to convert that to polar, then you do the division. So I have 8 comma negative 4. I get 8.944. Then the angle that you get is negative 26.57 divided by. Then if you convert the J10 to polar, what you're going to have is 10 and the angle of what, 90. That's what you're going to get. You can try it out on the calculator, but that's the way it is. So here I'm going to say it's the 8.944 divided by 10, giving us 0.894. Okay, 894 there. Then the angle of here, those you're going to say minus 26.57 minus 90, so which is simply if you say minus 26 point 0.57 minus 90, which is going to give us minus 116.57. Okay, so the best thing to do right now, again, convert that back to rectangular from polar. So that's 0.894 comma negative 116.57. What you get is negative 4. Okay, then that's a real part. The imaginary part is minus j 0. No, this is negative 0.4, not negative 4. So this is 0.4 minus 0. Minus j 0.8. Remember to say we are multiplying by what? The v minus v7 in there. Okay. So now, maybe I can try to do the expansion in advance. I can say I have minus v plus 96 minus j48 is equals to. So I'm going to say I'm going to multiply the 0.0, like we are going to expand this part in simple terms. So that will give us minus 0.4v. Okay, 0.4v. Then that will give me plus 0.4 v Thevenin because of the negative and negative there. Then I'm going to have minus j 0.8 v plus j 0.8 v Thevenin. Okay, so it's very, very important that we become a little bit careful when dealing with this here. Okay, so we can come back here and say, oh, all right, what do we have? I can bring these that have v and v Thevenin on the other side. So meaning I'm going to have something like minus v. Okay, minus v plus 0.4 v there. Then which other part has v? Is that part. That's going to give me plus j 0.8 v minus 0.4 Thevenin v Thevenin there. Okay, then the other one is minus j 0.8 v Thevenin is equals to. So everything that was here, I've brought it on the other side. So what I'm going to do is that I'm going to pick this part and take it on the other side. That would be minus 96 plus j48. Okay, so here I can you observe to say for this part, okay, you can simplify it a bit again. So that's simply like 1 minus 1 plus 0.4. There is say minus 1 plus 0.4. That will give us minus 0.6. So I can do that. I can say it's minus 0.6 v. So I can factor out the v. That will be your v open bracket minus 0.6 plus 0.8. I mean j 0.8 there, like that. Then I can also do the same here, but let me use minus instead of plus. Let me use minus v Thevenin open bracket 0.4 plus j 0.8 is equals to minus 96 plus j 48. Okay, have we done the right thing there? Yeah, it's okay like that. So now I can go to the other node. This one seemed to be a bit longer. The other one is not really as long, but at the end of the day, everything that we are doing right now is worth it. It's very important that we do the correct computation so that at least what we get is going to give us the right answer. So this thing can get a bit long, and it is very easy for you to get bored. I advise you not to. Okay, so at node V Thevenin, you observe to say you are going to have your I2 being equals to I3, and your I2 is simply V minus V Thevenin divided by your J10 is equals to your I3 is simply equals to V Thevenin divided by what? Divided by 5. So once again here I can write this as my V minus V Thevenin is equals to J10 V Thevenin divided by what? Divided by 5 there. Okay, so here you can kind of like maybe try to waste your time by converting this to polar, like convert to polar, convert, like then do the division whatever, and it's the same thing as if your j is x, so it's like 10x divided by 5 is still going to give you something that you can work with. So I'll just simply write this as my v minus V Thevenin is equals to, that will give me j2 v what? V Thevenin there. Okay, so you observe to say I can say it's v minus V Thevenin minus j2 V Thevenin is equals to 0. So I can bring it here and say I have my v minus V Thevenin, okay, open bracket, I'll have a 1, okay, 1 plus j2 there, j2 is equals to what? Is equals to 0. So this is simply you dealing with simultaneous equations. So the best thing that I can do here, I'm very glad with the fact that this is just v with a coefficient of what? Coefficient of 1, like it's multiplying by 1. So I can multiply it by this that I have there, so that at least I'm going to do the elimination and remain with V Thevenin, and V Thevenin is actually what I'm looking for. So we are going to say it's the v multiplied by 0.6 plus j 0.8, okay, then that would be minus, so we're going to have V Thevenin here, so I'm going to multiply this by that. So it's really up to you which method that you're going to use, whether you're going to convert that to polar, then do what you need to do, or just the way it is, you're still going to get the same thing. I'm just going to multiply the way it is. You can try using polar, then we see if you're going to get the same thing. So that's 1 there plus j2 there. So minus 0.6 by 1, that is still 0.6. Then 0.6 by 2, that will give us minus j 1.2. Then j 0.8 by 1, that is plus j 0.8. Then 0.8 by 2, that is going to give us what? Minus 1.6. Why is that minus? It's simply because 0.8 times 2 is 1.6, then j times j is negative, that's why we have that negative there. So what j times j simply means that your j simply equals to the root of negative 1. So if I square this, like you square both sides, you're going to get what? Negative 1. That's why j times j is what? Negative 1. So at this point you can say 0.6 plus 1.6 is going to give us negative 2.2. Of course I didn't have to say minus, but when I add them I just have to remember that I'm dealing with a negative. So here I have minus 1.2 plus 0.8. I'm going to get minus j 0. What? J 0.4. So I can put the minus 2.2 minus j 0.4 is equals to 0. Okay, So I no longer need this part. So you observe to say, if we do the subtraction, if we subtract the if we do the subtraction here, this part is going to go. Okay, I can get rid of that. That part is going to go when you do the subtraction. Then this one is going to be what? It's going to be a plus. Let me just try to move it a bit up like that. So what do we have? What we have is simply more like you are saying your minus v Thevenin. Okay, I'll say open bracket. It's more like I'm factoring that out. Okay, then I'll have like 0.4 plus j 0.8. Then since this is a minus, for me to have a positive v Thevenin, by that to give me a negative, that is supposed to be that's supposed to be plus 2.2 plus j 0.8 is equals to, that will still remain as minus 96 plus j48 there. Okay, so we just have to make sure we do the right thing at this point, because that's going to affect our answer. Okay, so this by that, we still get that. Then negative of this by that is going to be negative. So because that's positive, it's going to be negative. Same applies to the other one. Anyways, I'll take it by faith that is correct. I believe it is anyway. Yeah. So we are going to have minus. By the way, you can get rid of this and that, it becomes positive. So that's going to be v Thevenin open bracket. So you are going to have your 0.4 plus your 2.2, giving you 2.6. Okay, plus you're going to have your 0.8 plus your 0.4, giving you your j 1.2. Remember to say this is equals to 96 plus j 48. So now you can divide both sides by that. That will be like your v Thevenin will be equals to your 96 plus your j 48, divide by what? Divide by 2.6 plus j 1.2. So the best thing that you can do here is that convert that to polar, then do the needful. So it is 96 comma 48. What I get is 107 or 107.331. Then the angle I'm going to get, I'm getting 26.57. I divide by converting the other part to polar, so this is 2.6 comma 1.2. Okay, I'm going to get 2.86 wait a minute, 2.864. Then the angle of 24. Okay, let me move this on the other side. So we have like v Thevenin being equals to 107.331, then the angle of 26.57, divide by, that would be like 2.864, the angle of 24.778 there. Okay, so we can do the division there. So you can say 107.331 divided by 2.864. What I get is 37.476 with the angle of what? The angle of that's 26.57 minus 24.78. That's going to give me 1.79 as the angle. Okay, so now to come up with my maximum power there, I have everything that I need now. So I'll just come and say maximum power, or power max, is equals to the absolute value of what I have, which is this one, which is already positive. I'm going to say it's 37.476 squared, divide by what? Divide by 8 multiplied by the 3.415, which is this value that we calculated there. So we can say it's 37.476 squared. I get 1000 1404.45056 divide by 8 times 3.415. Got to put the 1 here. So here I'm getting 27.32. So we have the 1404.4 point 45057 divided by 27.32. The value that I get as my power maximum power, is equals to 51.40778, but I'm going to round up to 3 decimal places, so that'll be 408 watts as my maximum power. And that's simply how you go about it. So it was looking a bit complicated with the fact that you are solving a simultaneous equation that has some complex numbers in it, but you just have to be patient and you eventually reach at the final answer that you are looking for. And for such questions, I urge you to be very cautious with how you convert, either from polar to rectangular or from rectangular to polar, or how you multiply them. You really have to be very careful. It's very easy for such questions. It's very easy to make a mistake. These questions are very simple, but it's also very easy to make a mistake. And yeah, I don't think it's a good idea to make a mistake at such a point. Yeah, so otherwise, thank you very much for watching. Thank you very much for your support. Yeah, we will see you in the next video. Thank you.